Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Today we see the crystal field theory, and in this crystal field theory lecture 2 we learn about the group theoretical symbols. When we studied the crystal field theory, then we mainly studied about the interaction between d orbital and ligand. So in the first lecture we have seen the shape of d orbitals, and there are 5d orbitals. So every times there is not need to write the name of d orbitals. So depending upon the symmetry, the d orbitals are grouped into certain symbols, and they have given certain group symbols. And we see in this lecture that group theoretical symbols for these d orbitals. So in the group theoretical symbols, firstly we see that dx square dash y squares and dz square orbitals, they are of one type of symmetry, and they are collectively denoted as EG group of orbitals. Then remaining 3d orbitals dxy, dyz and dxz, these orbitals are collectively denoted as T2g orbitals. Now we see in T2g, what is the symbol T? So here symbol T means there are three degenerate orbitals. Means if we take dxy, dyz and dxz, then these three d orbitals have same type of energy, and so that is called as degenerate orbitals. And these three are degenerate orbitals, and for that three the T symbol is used. Means these all the three have equal energy orbitals, they are degenerate orbitals. Now what is the symbol G? So G stands for Geared. This is the German word, and in German that is called as Geared, and meaning of that is even. Meaning of G is even. So the orbitals is shade geared if it is centrosymmetric. Means it has same signs of the wave functions at the same distance in opposite direction from the center of symmetry. Means if we take any orbitals, and in that orbitals there are some lobes, and the opposite lobes, if they have same wave functions, they have same wave functions, means there is plus plus charge, minus minus charge, that is same charge, then that is called as geared. For example, we take the p orbitals. So px orbital, py orbital, pz orbitals. Then d orbitals, dxy orbitals, dyz orbital, dxz orbitals, and we see their lobes, its wave functions, and from that we get idea about this geared. Now the second, ungeared. So ungeared, here we use the symbol U for ungeared, and meaning of that ungeared, that is the uneven. Means the orbitals is ungeared if the changes the signs of the wave functions at the same distance in opposite direction from the center of symmetry. That is called as ungeared. And for that purpose, we have to take some examples, and from that we get idea about this. So we take the s and d orbitals. So in s orbital, you know that shape of s orbital is spherical. So along the x-axis, y-axis and z-axis, s orbital is spread, and along the x-axis, y-axis and z-axis, wave functions of that s orbital is same. And in that case, that s orbital wave functions are called as geared orbitals. Like that in case of the d orbital. So if we see the d orbital, then there are four lobes. So if we consider two opposite lobes, then that two opposite lobes have same wave functions. Two opposite lobes have same wave functions. For that purpose, we draw here one d orbital. So here we can draw the one d orbital. In this way, we can draw the lobes in between the axes. So if these two lobes, opposite lobes, have plus wave functions, then these lobes have minus wave functions. You see here plus and plus. So opposite lobes have same wave functions. And when opposite lobes, if it carries same wave functions, then that is called as geared. So in case of the d orbitals, all the d orbitals have of geared type, means opposite lobes have same wave functions. And so s orbital and d orbitals are geared, while p orbital and f orbitals are ungeared. P orbitals and f orbitals are ungeared. So generally Eg orbitals are doubly degenerate and T2G orbitals are triply degenerate. So symbol E is used for doubly degenerate and symbol T is used for triply degenerate. So in addition to these symbols, sometimes the subscripts 1 and 2 is also used. So we write T2G, EG or E1G. So what is this 1 and 2 subscripts? So these subscripts 1 is used when the orbitals do not change the sign on rotation about the Cartesian axis. So when we rotate the orbitals along the Cartesian axis, and after rotation, its signs, its wave functions are not changed, then at that time subscripts 1 is used. Now we see when we use this subscript 2, this subscript 2 is used when the orbitals are rotated and they do not change the sign on rotation about the axis diagonal to the Cartesian axis. Means when we select the axis diagonal to the Cartesian axis, means in the 45 angle to the Cartesian axis, that is called as diagonal. So when we select the axis diagonal to the Cartesian axis and we rotate that, after rotation, if wave functions are not changed, then at that time we use the symbol or subscript 2. So simply remember that. Again we repeat that when we use the 1, that is used when we rotate the lobes of that orbitals, and along the Cartesian axis when it is rotated and its wave functions are not changed, then that is 1 is used. And when we select the axis diagonal to the Cartesian axis and after rotation, the wave functions are not changed, then we use the subscript 2. So in metal s orbital, that is designated at A1G. The metal p orbital are designated at T1U. So that T1U means triply degenerate and it is the unsymmetrical or ungeared orbitals. Now we see the degeneracy of d orbital. So when all the 5d orbitals are present and they have not any interaction with ligand, then 5d orbitals remains degenerate. So we say in the pre-metallic state, all the 5d orbitals are degenerate, means they have same energy, equal energy. But when the d orbital interact with the certain ligands, then ligand can break the degeneracy of d orbital. So firstly, that ligand when interact with the metal, then metal orbitals are converted into excited state, and that is the ions, that is called as symmetrical field. And in that case, that metals are split into two groups depending upon the symmetry. And when metals are split into two groups, then that is called as breaking of degeneracy. Breaking of degeneracy or splitting of the d orbitals. So in octahedral complex, when that d orbitals are split, then that is the crystal field splitting, or we say the crystal field splitting in octahedral complex. So in octahedral complex, 5d orbitals are split into two groups and there is formation of two groups. In that two groups, one group carries 3d orbitals and other group carries 2d orbitals. So that 2d orbitals mean that is the Eg orbitals. 3d orbitals means that is the T2g orbitals. So just we have seen in point symbol dxy, dyz and dxz orbitals are called as T2g. Dx square dash y square and dz square orbitals are called as Eg orbitals. So from this point, we use only the symbols that is T2g and Eg and not the detailed name of the d orbitals. So we get two group of orbitals, one is T2g and Eg. Out of that, Eg orbitals are repelled more and it acquires higher position or higher energy. T2g orbitals are repelled, both T2g and Eg are repelled with each other, and in this case T2g orbitals acquires lower energy and Eg orbitals acquires higher energy. So this lower and higher, it depends upon the symmetry of ligand with metal. So we know that metal orbitals in Eg are along the axis and ligands are also the along the axis. And so in case of the Eg orbital and ligand orbitals, there is face-to-face repulsion is carried out. And when face-to-face repulsion, then at that time Eg orbitals are repelled more. In case of the T2g orbital, instead of the face-to-face interaction, diagonal interaction is carried out. And in that, repulsion is comparatively less. And so in T2g orbital, they are repelled less, it acquires lower energy, and Eg acquires higher energy. Now, energy difference between T2g orbital and Eg orbital, that is called as 10 dq, or in octahedral complex that is called as delta O. So we give the symbol between energy difference between T2g and Eg, that is 10 dq. Now, the energy, it is at the excited state, that energy is called as average energy or Berry energy. And energy below the average energy, that is called as stabilization energy. Energy above the average energy, that is called as destabilization energy. Now, the energy below the average energy or Berry energy, that is, we say the minus 4 dq, and energy above the average energy, that is called as plus 6 dq. So plus 6 dq means that is the endothermic reaction, and minus 4 dq means that is the exothermic reaction. So this energy we can give in the other notation minus 2 by 5 delta O, because total energy is delta O. It is divided into 5 orbitals, so minus 2 by 5 delta O, and this upper or destabilization energy is plus 3 by 5 delta O. So in this way, when d orbitals energy or degeneracy is break, then d orbitals are split into two groups, and that is called as splitting of octahedral field, and there is formation of crystal field splitting, and this crystal field splitting is observed in this d orbital. So this crystal field splitting is observed in between this T2G and EG, and there is formation of this. So this energy is observed when that bond is formed, and that is called as crystal field stabilization energy. So when that d orbital split into two groups, then one acquires lower energy and one acquires higher energy, and in between that orbitals there is filling of electrons. So by calculating the energy between that, we get the stabilization energy, and that is the called as crystal field stabilization energy.